Hey guys, it's Naavya Vig, and welcome to the next video in the Computer Science 4 Community CSC's series on AI, where today I will be talking about neural networks, what they are, how they're used to train AIs, and all that good stuff. And, well, without further ado, let's get started. If you guys haven't watched my previous videos or don't know me, I am Naavya Vig. I am the AI Development and Curriculum Manager, and I also record the videos for CSC's AI series, and I teach a lot about AI, so if you guys haven't watched my previous videos, please go ahead and do those. And without further ado, let's get started. Demystifying neural networks. Let's get started. So first of all, let's introduce ourselves. Neural networks are complex models used in machine learning to mimic the human brain. See, neural networks are basically designed by the way us humans think. So how do we think? What causes us to fire those neurons in our brain? What causes us to be human? That's what AI has taken inspiration from, and that's basically how neural networks are designed to be, which is actually really helpful, as I'll explain in a bit. Understanding the weights, bias, and activation functions, I'll get to those as well, is crucial to comprehend their inner workings. So, neural networks consist of layers of interconnected nodes where each connection has a weight and a bias, and the activation function determines the output of each. So basically, you guys probably don't know what nodes are in neural networks yet, and I'll explain those in a bit, but let's take nodes for example. The weights control the strength of connections between nodes, while biases shift the activation function. Let me just quickly demonstrate what that is real quick. So, this is an example of a neural network. So we have an input layer, hidden layers, and an output layer. Now this all looks pretty, foreign, pretty weird. So let's take an example. Let's say we were given a black and white image of a person. That person could be smiling, frowning, neutral expression, anything, right? So if I looked at the image, I could definitely tell you, hey, this guy's smiling, this guy's frowning, this guy's not smiling or frowning. But how do we teach an AI how to do that? Let's take that as the example for how I'll teach you guys neural networks. So, the input layer is basically the image we're giving to the AI. Now, here we only have four nodes in the input layer, but in an actual scenario, there would be hundreds if not thousands of these. Let's take a 20 by 20 image of a person, either smiling, frowning, or whatever, 20 by 20 pixels. That would be way too blurry, but let's just take that. For each pixel, there would be a node. And remember, it's black and white, so each node can either be each node could either be white, each node could be black. From 0 to 1, there's a value, 0 being black, 1 being white, and decimals in between. And each and every single pixel would have one of those. And each and every pixel corresponds to one of the input layers. So for example, we could have our little grid of bunches of pixels. Obviously, in a real image, there would be more. Ignore my scrappy drawing. The value of this pixel would go in this node, let's say 0.5. Value of this one would go here, 0.4 here, and so on, right? And like a bunch of these to like the last one. There would be like hundreds if not thousands here. Let me just get rid of that real quick. So basically, that's what the input layer would be, just the values that we put in. Now the hidden layers, this is where the AI magic happens. Basically, this is where the AI really comes into action and sees, is this guy smiling, frowning, or whatever. So clearly, we can't really hard code this into an AI, so that's why it's trying to learn itself using these. And I'll get to these in a bit. And for output layers, let's just ignore this node exists. Pretend this one doesn't exist. This output layer would be smile, this output layer would be frown, and this output layer would be meh. Smiling, frowning, or not either, right? Essentially, our input is all the pixels of the image, our input is the image, and our output is whether it's smiling, frowning, or neutral expression. Now, let's go into depth on how these hidden layers, how these nodes really play into action, and how they, actually decide whether it's smiling, frowning, or whatever. So, let's zoom in on one of these nodes in specific. So, take this to be, let's say, this node right here. Basically, this node is getting fed the input value from the input layer, and it needs to transfer this value over to the next node, right? So, each and every one of these lines has what's known as a weight. So let's say, for instance, this weight is 0.7, and let's say this node from one of our pixels is 0.5, and there's also another node connecting to it, let's say this one, which has a weight of 0.7 as well. Actually, let's say 0.5, and this node right here, this one has a value of 0.4. So this node's value, and of course there would be more and more nodes down here, but let's just simplify down to these two. This node's value multiplied by this would be 0.7 times phi plus whatever value is over here, so 0.4 times phi, and either way this would all come down to one big number, right? This number would then be transferred over to the next node, which is over here, and then, or in here, and here, and basically all of this monstrous calculations, all of this, transferring values and nodes and everything would happen throughout the layers until it reached the final layers, where each of these three layers, let's say these are the three final ones from, all of these, connections and stuff. This one's happy, this one's sad, and this one is mid. Now, at the end, the AI, assuming we have a good neural network, it would be something like this one would have a value. Let's say we had an image where, the person was happy. So, after going through this whole neural network madness, let's say this one had a value of 0.9, this one had a value of 0.1, this one had a value of 0.4. Basically, whichever one is closest to 1 would be the one that's selected. So then the AI would say, hey, this image is happy because after all of these messy calculations we did, we resulted with this image. Simple enough. Okay, maybe not that simple, but yeah, you get the point. We put in an image, goes through a bunch of numerical calculations, we get an output. That's just the general scheme of things. But the real question is, how does the AI know which numerical calculations to create? Like, how does it know which weights and biases to use, which additions to use, which multiplications to use, how much should this one be, how much should this one be? How does it know that, right? The correct answer is, it's random. Let me explain. So, back to our previous example of the nodes. If we had, let's say, from this node, a random weight of 0.7, a random value of 0. This is not random, this is given to us by the user. A given value of 0.5, random value of 0.7, 0.7 times 0.5, this one is 0.35, plus whatever value we want, so plus another random value, so 1. Then this would have a final value of 1.35. Alright, perfect. And then this value, we would put an activation function on it, and the activation function is basically just another function that, does some more math madness to it. Let's say some more math madness function results in 0.641 or whatever. Right? Now, with this number, we would then, remember, this is random. Whatever plus 1 added is also random. But then at the end, let's say after all this random madness, we have a neural network that returns happy, sad, mid, image. Hold up, it's glitching. Let's say it returns sad face, because once again, remember, let's say this is 0.9, this is 0.2, or whatever random values. Let's say it returns sad face. Obviously, this is wrong. So what the machine does is, it says, hey, the correct answer was happy face, but the machine put sad face. So what the machine's going to do is, it's going to go through all of these calculations again and find where it went wrong. It's going to go, hold up, that previous 0.7 should have been a 0.5. That previous plus 1 should have been a plus 2. And it's just going to go back and do so many more calculations using calculus and algebra and other funny maths that I can't get into this video. So basically, it's going to go through all of this stuff again and then alter the values so that in the next iteration, let's say it returns neutral, except this time it got a happy value of 0.5, a sad value of 0.2, and a neutral value of 0.8. this is much closer to happy than it was last time. So then the neural network's going to go, amazing. Let's adjust these values using calculus and other funny maths again. Oh. Right? Now, let's say it goes over here, 0.6, 0.1, 0.2. It returns happy face. Perfect. We got the desired output, but by a very small margin. 0.6 is nowhere close to 1, as it should be. So then it just keeps running these mathematical calculations again and again and again. Keeps doing it to itself every single time. So that way, at the end, we can result in a purely trained neural network that takes in these images, learns the relation by constantly updating the values within them, so that way at the end, it gives us a good number. Back to our presentation, we can understand that, well, understanding weights, biases, and activation functions, which I didn't really get into, but it's not that important to understanding the main part of neural networks, is very crucial for fine-tuning and optimizing neural networks. So, by learning all of these different nitty-gritty things, we can then learn to create our own neural networks from where we can train machines to do all sorts of things. ChatGPT in and of itself is one big neural network that has to do a lot with text. There's more to it, obviously, but that's basically the main part of what neural networks are in its core, right? And misinterpreting weights and biases or selecting inappropriate activation functions can lead to poor performance and unreliable predictions. So yes, careful consideration is needed when designing neural networks. So in the end, to sum everything up, neural networks take something, try to find and constantly, keeps running maths in and of itself to find relations between, the pixels in the image or the values in the inputs to give us a proper desired output, right? So basically that's just a big general overview to how neural networks work, and I hope you guys found this video enjoyable. Please be sure to like and subscribe to CSE's channel, and I'll see you guys in the next one. Bye-bye.